Question 5 is on the topic for partial fraction. So in Sec 4, there will be some questions where partial fractions will be mixed in with differentiation, and it will be mixed in, or it can be mixed in with integration. So subsequently, you will be learning this part. So, but anyway, right now, this is a pure partial fraction question. So for those of you, if you recall the partial fraction, right, the three cases. So there are three cases of partial fraction. So the cases is actually dependent on the denominator. So if you observe the denominator, in this case, this is a linear. So this is a quadratic function that cannot be factorized. So this fall under case 3. So this fall under case 3. So actually, if you look right, okay, under case 3, if this is linear, the numerator is a number. If this is quadratic, the numerator is linear. So this person looks like there's nothing wrong with it. So he quickly observed the denominator and decided that it's under case 3. So looks very correct. But why is he actually wrong? So this is a common mistake. Why people got it wrong? Most people, when they do partial frac, they will fail to check for proper and improper. So if you look at the numerator is a cubic function. So that is a degree 3. For the denominator, it is a product. So what is the degree for this product? You can just look at the highest multiplication. So this is x cubed. So the denominator in this case is a degree 3. Denominator is degree 3. Numerator is also a degree 3. So this is considered under the improper fraction. So why is he wrong? Because the fraction is improper. So you got to explain why is it improper. So you explain the degree. So before that, right, you explain that this is degree 3, the denominator is degree 3, and hence it's the improper. So the first step for improper should be a long division. So you explain the degree, and the degree is the condition that indicates whether is it improper or not. So for improper fraction, the first step should be a long division. So everything has to be written out clearly. You talk about the degree of numerator and denominator, and that becomes the improper fraction. Therefore, the first step should be a long division. Because the purpose of the long division is to get to a proper fraction. Okay, so subsequently, your job is to do the correct one. Okay, so when you do the long division, the numerator should be inside, the denominator should be outside. But in this case, the denominator needs to be expanded first. If you do not expand, then you cannot do your long division. So here, right, is one possible situation where people will make careless mistake. So sometimes some people, so here is a chance of making careless. Okay, let's put a star. So there's one chance that you make careless. Okay, then let's do the long division. So when you put the long division, the numerator is inside, the denominator is outside. So I won't show the long division, you do it yourself. You will be getting this. So usually long division is another chance of careless mistake. So if your long division is wrong, then your remainder will be wrong. So a lot of people, after the long division, they will kind of forget. So what do I do after the long division? Remember, the purpose of the long division is to obtain a proper fraction. Where is the proper fraction? The proper fraction will be here. So the original improper fraction will become a 2 plus the remainder over the denominator. So I will get back the original bracket. And you check, this is a degree 2. This is a degree 3. So it actually become a proper fraction. So here comes the proper fraction. So with the proper fraction, then you apply your case 3. So with the proper fraction, then you apply your case 3. So it should be a over this plus bx plus c over x squared plus 1. So if you've forgotten the step, so what happened after this? So if you have apply K3 on it, try to make same denominator. Making same denominator allows you to compare with the proper fraction. So once I do that, I will be able to compare. If you take a look, the denominator is the same as the original proper fraction. So where does the comparison come from? The comparison will come from the numerator. So when I get the numerator, that is where I gotten my identity. So there's a lot of technique involved in a partial frac, which there is a lot of chance of making careless. Sorry, I should just take the numerator equal to, so I'm doing this comparison, the numerator of the proper fraction and the numerator here. So how are you going to solve the identity? So the method of identity, sometimes it's expansion. Sometimes you expand the right side and you go and compare the coefficient. Or sometimes it can be done using the substitution method. So in this question, right, I kind of like do a substitution. The bracket is an indication that I can sub x equal to 2. The x here is an indication that I can sub x equal to 0. So right now there are 3 unknown. So if you would like to solve 3 unknown, you will need 3 values that you can sub. So if you sub these 2 already, the third value that you sub can be any value. So usually I'll prefer the simpler one. Then I will be able to solve my A. Okay, you can give it a try and see whether you get or not. So don't stop here, because that's not your final answer. You're supposed to return your ABC. You're supposed to return your ABC back to the case 3 format. And the final answer will be this. So give it a try. So usually partial frac is quite lengthy. And there is for improper, sometimes it can go up to 7 marks. So in this one, there's only 6 marks.